So when we're looking at this map, if we look at the point 1, 1.5, which is the red dot, if we want to know if f sub x is positive, negative, or 0, well, what that says is, as your x increases, does your z increase or decrease, right? Or, yeah, exactly. So because x is your input. So here, and we're kind of just holding y constant, right? Like, think of y as a constant. We're moving the direction of the x-axis. As x increases, so as we move this way, from that point, is the z value going up or down? Well, let's make sure we know what these z values are. This is negative 0.4, this is negative 0.6, this is negative 0.8, this is negative 1, negative 1.2, 1.4, 1.6, 1.8, and then you're at negative 2. So as you move to the right on the x-axis from that point, what's happening with your z value?
It's constant.
It's not constant.
Is it always 0.8?
You're moving this way. Moving this way. You're not following the squiggle. You literally, when you're talking about f sub x, you have to be parallel to the x-axis. You're in the x direction. So if you are moving the direction that that arrow is pointing, pretend that arrow is actually pointing to the right. So say we have, say it looks good. I don't remember where we were. Something like that. Is our z going up or is our z going down? It's going down, right? Yeah, but this is instantaneous.
So just the next step is what you're looking at?
I'm just looking literally at that moment, just a tiny bit to the right. Is my z going up or down? Remember, we're not talking about like going all the way over here. It's not average rates of change. These are instantaneous. We're still derivatives, right? So we're still talking about at that moment. Really, technically, it's at that dot. But just because we're human beings, we need to think about it with a little bit of movement, right? So as you go, yes.
So it's negative because it's kind of getting closer to the negative 1.
Because your z values in this direction are going down. Now, if we were here, it'd be positive because the next z value over is higher, so we're actually going up.
Okay.
Yeah. All right, let's talk about f sub, okay, well, I'll wait and check in a minute. Let's talk about f sub y from that point. So f sub y says x gets held constant, and we're going this way. As y increases, what's happening to z? It's still decreasing. The z values are getting lower. Does everyone see that? So both f sub x and f sub y would be negative at the first point. You got it? Nobody did anything there. You got the f sub x. Did you get f sub y? It's just real light. Yeah, okay, good, good. I think so. Yes, good. You guys are acting like you didn't get it, but every single group got it right. Okay, let's take a look at the next one. Well, except for you guys that didn't put anything.
We should go.
All right, so now we're over on this blue dot, and just so you know, so this is 0.2, this is 0, this is negative 0.2, right? Okay, so if you're on this blue dot, and I go in the x direction, as x increases, what's happening with z? It's decreasing, it's going down. But if you look in the y direction at this point, it's hard to see if I draw too much on top of it. Make it smaller. What do you think the dz dy is at that point? Partial z, partial y. As the y increases, what's going on with the z? At that point. Yeah, I would say it's 0. It's just staying the same. It's kind of like a max this way. So anyway, so I would say 0 for that one, which looks like a lot of you did. So even though you guys are acting like you didn't get it, it looks like at least one person in each group had some understanding of what was going on. All right, but we're not done.
No.
Okay, there's more. So the function plotted in the figure, I'm going to rewrite this so that those of you in the back can see this well. we have an actual function. Is x cubed minus xy squared minus 4x squared plus 3x plus x squared y. Isn't that awesome? Calculate the actual values of the partial derivatives at 1, 1.5, and 1.2, 0.6, and see what you get. Yeah, do it on the boards. Yes. Yes. I have the answers already written. Whoops. I don't know why there's an X there. Is that supposed to be an X? Did I have a mistake on my first one? So, f sub x, so we have 3x squared minus y squared minus 8x plus 3 plus 2xy. Yeah, that's your f sub x. Your f sub y, so when you do partial y, you get 0 minus 2xy. That's supposed to be like stuck in there somewhere. Okay, there we go. Plus x squared. Yeah, there we go. Okay, so there's our f sub x and our f sub y. And when you plug in your numbers, so your slope for your first partial at the first point was negative, for partial x was negative and partial y was negative, which matched what we got. And then same thing for the second one, partial x was negative and partial y, if I do my math right, was actually 0. So, which is what it looks like everybody got.
We all win.
Good. Wait. Yes. Okay. Yeah, very good. Okay. All right. We'll do more contour maths. I like contour maths. I think they're kind of fun. But anyway. But today is not contour math day. Today is second day of partial derivatives. Double partials. No primes. There are no prime symbols in partials. We will find out. Okay. Alright, so this is section 14.3b. Second partials. So, suppose f of xy is 3xy squared minus 2y plus fx squared y squared. Take a minute and find the first two partials. Find f sub x and f sub y. I'm going to put in a screen. Okay. Everyone got their partials? I don't think I have any answers in here. Oh, I do. Look at that. Hey, that makes it so easy for me. I don't have to like actually even think. Okay. So first partial x is 3y squared plus 10xy squared. Is that what you guys got? Yes. Okay. Partial y, 6xy minus 2 plus 10x squared y. How are we feeling about partials? You're fine? Yeah. Okay. All right. Good. It's time. It's time to do second partials. So I'm going to have you guys see if you can figure out. I'm not going to teach you. I will, but right now, let's just see if you can guess what f sub xx is, f sub xy, f sub yx, and f sub yy. Okay?
That makes sense.
I don't get it.
Okay,
Do you want some guidance, or do you want to try and guess it out?
Take the
You take that partial x.
So f sub xx would be the partial, like partial x, like you're doing partial with respect to x on your partial x.
Yeah. How about the second one? What would be like?
What do you do?
What with y? So next grouping or like the second one is next grouping. XY. So in XY you take that f of x, but then you're gonna do partial with the y instead.
I get it. I got it. Okay.
Gentlemen, you don't need any laptops out right now.
Got it. So let's see. Bottom blue. Then
Did I not identify? Let me see. Yeah, I should have put at that point. I think it's just because I had it in the problem. But yeah. Okay. All right, Vikram, how are you? Yeah? Life is good? Okay. So, what did you get for f sub xx?
3y squared plus 10y squared. Or
You're close.
13.
10y squared.
Well, now why no 3y squared?
What?
So technically the right answer is actually just 10y squared.
Oh.
Why
Oh,
would
'cause
we?
that's a constant sign.
Yes. Yes. So what would, so tell us, so Vikram, I'm still with you. How did you come up with f sub xx?
You do partial x of the partial x.
Yeah, it's partial x of partial x, right? Does that make sense? Okay, so now f sub xy, so Laura, since I've been talking to you, tell me what is f sub xy? 6y plus 20xy is right. And tell me what that means.
So that you take the partial y, partial x.
Exactly. You're doing the partial y, partial derivative with respect to y of the partial derivative with respect to x, right? Okay, good. And then so Michelle, f sub yx, what'd you get?
6y plus 20xy.
6y plus 20xy. Very good. So you're starting with partial y, and then you're doing partial x of this function. And then, so Dursa, f sub yy.
Oh, I got a question.
Yes.
Like, so which x is so for like the second one or second or third one?
Mm-hmm.
So would it be like you do the partial x of the function like the x? No, what like so which x is no the
This is okay. You're doing the partial y of
the
partial x.
So the first like letter is the equation.
Yes, is the function you're doing the partial of. Yeah.
Okay. And the second one is just like the partial. Like,
Which letter you're doing it with respect to?
Okay. So then like would that the last one be like 6x plus 10x squared?
6x plus 10x squared. Very good. You got it. Well done. Okay. So Nathan, what do you notice about the two middle partials?
They're the same thing.
No way. Okay. They are the same, right? Woo. Okay. So, yeah.
How do you know?
Oh, and we'll do that in just a second. and just evaluating it. No, you can do this in 2 seconds, guys. It's just plugging in numbers. Okay, it's the next slide that I talk more about this. These partials right here, f sub xy and f sub yx, those are called mixed partials. So we'll get into those in just a minute. But first, let's just make sure you can find the second derivative evaluated at a point. So you've got your 4 partials, second partials right there. Go ahead and find the second partials at the point -1, 2. I give you 30 seconds.
This is not calculator.
This is no calculator. You can do this.
-6. Minus 40. Yeah.
You just plug it in, right?
And it's the same as the
I don't even know what you're talking about.
12, so then it'd be minus 40.
There's
Well,
four, that there's 4 second partials.
So they don't always have to
You
be
get like
They won't be. If the middle two will always be the same if your partial, if your derivative is continuous. Yes, that's what it's doing. And you can have different terms.
So what? Why?
Yes.
But why?
Wait.
Presumably, if you
Oh.
go like
Oh,
infinite-
wait, that is true.
No, wait,
But that's kind
So
of
we
like
negative, so
saying like
-6.
how, like when we
Negative
just
6
did regular derivatives,
plus
how
10.
many derivatives do we
So
have?
4.
Yeah.
So we really,
I can't-
we could have
So 40.
a whole bunch of derivatives, but for the most part, most of the
Yeah.
applications are right, and it's just the same.
And if you like go on, so but I got negative x, y, and f.
What was the time? Yeah.
Yes, you can have f sub x, y, and f.
You need to add 12.
But what if you have f of like x, y, x is
How, wasn't it downtown?
Yes.
So what do you get for the,
Yeah. They should all of those
12.
functions
Negative
as long as that's.
12.
So it's like if they have the same number.
So for the
of
f
x's,
of
y,
y, you got.
40. So negative 28. Right?
Yeah.
So
top
saying
is
f sub x,
40.
x, y, y would be
40, then
Negative
-28,
28.
negative 28, and then 4.
Wait, one sec. I'll show you what I mean.
Okay.
I'm
It's
at
so weird.
I haven't
Like,
tried
the
to
first
be
thing we
honest,
did, we
go out
got there
that
and the
far
guy
to
brought us
see.
into his office.
Hey.
To like 3, 4, kind of like 40 minutes.
All right, let's check our
In his office, he
numbers.
had, like a circular table.
All right.
So
Oh,
he's standing
well,
at his desk,
how are
he
you?
has I was sitting in a
What'd you
chair
get for the
that
first
was
one?
directly away from the guy. So I had to, like,
40.
turn
That's
halfway
what I got.
and
Good
he
job.
turned
All right, Ryan, what'd you get for the second one?
Negative 28.
-28. Good. Rishi, what'd you get for the next one?
Negative 28.
-28. And Danny? 4? A 4. Very good. Okay. All right.
Like I said, I don't know who I am.
Did you?
If I am who I am, then I am who I am. You know what I'm saying? Because if I am who I'm not, I'm not who I am.
Are there any questions on this? All right. So, f sub xy and f sub yx are called mixed partials. They are partial derivatives with respect to mixed variables. And so here's what I wrote. This is what I've been kind of saying. As long as the derivatives are continuous, the mixed partials are going to be the same. If the derivatives aren't continuous, you can have different mixed partials. But as long as the derivatives are continuous, then your mixed partials will be the same. Why is that nice? Because it will save you some time in some of these problems so that you don't have to calculate both mixed partials separately. You can just find one of them and then copy it for the second one, as long as you do the first one correctly, right? Yeah. Okay. Sophie, did you figure out like third and fourth mixed partials?
Yeah, so
So we know f sub x, y, x.
so like if there's 2 x's and 1 y, no matter what order, so if it's like x, y, x, 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 y, y, x, x,
Uh-huh.
those would all be equal.
Those are all the same. Okay. All
But
right.
then that's not equal, so if there's like 2 x's and 1 y and 1, and there's like 2 y's and 1 x and the other, those
Those will not be equal. I don't know that.
Oh wait. No.
I was looking to you for that. So,
No,
yeah, I thought you were
asking.
investigating. I have no idea.
Find them.
All I know, like, because I've never tried it, right? I know that, well, let's just think about it.
Okay.
If f sub xy and f sub yx are the same, like, these are the same, right? So then f sub xyx and f sub yxx have to be the same because f sub xy and f sub yx are the same, right? The same thing, f sub xyy and f sub yxy have to be the same. But f sub xxy doesn't have to be the same if I do xyx. This and this don't have to be the same because this and this aren't the same. You're doing a partial, although you're doing a partial y. Ooh, so now, I don't know. I honestly have no idea, right, how it works with the third and fourth partials, what's the same and
So
what's
I
not.
got it.
Whoa.
So
Bad joke.
Great, quiet, it's not even Wednesday. Okay, Sophie, what did you get?
one sec. I'm doing one more and then I just bullshit.
Okay.
It's simultaneous.
All right, while you're doing that, everyone else find the 4 second partial derivatives for z equals sine of x minus 2y.
Yeah,
Let's do a little
so
trick.
that's what it is. So wait.
Here, I'm going to write it on the board.
So it's like
So that really does equal f sub y, yx. Okay.
but at the
And then,
what's the notation for the f x?
alright.
I guess you just do this That's what it is.
Because they're not the same number of x's and
I'm
y's.
gonna go back to f what I posted. So it's just like if that's it.
I don't know.
Okay, now we haven't proven anything, it's conjecture, but it
this is
looks
what I think it is.
reasonable.
So for yx, we're using the partial x, right?
Right?
I like it.
Like that.
Yep.
So,
Alright, we'll call this Sophie's theorem.
for f
Alright.
yx, we use the partial x then?
So, of x, then you do the partial.
One of the things that we gotta make sure we know, so first of all, the derivative of sine is cosine.
Might as well.
Do we change the input when we do the derivative of a trig function?
No.
Never, ever. We never change the input. So the derivative of sine of x minus 2y is cosine of x minus 2y times the derivative of x minus 2y. And that's where your kind of partial part comes in, right? Do you need another 5 minutes?
I finished it.
So z sub x would be cosine of x minus 2y times 1 because the derivative of x minus 2y with respect to x is just 1, right?
Oh wait, never mind.
Is that okay?
Yeah,
You got
I
it?
was on the wrong thing and I thought I did everything wrong.
Oh, but you got it.
That's what I thought too.
Good. Okay. Z sub y would be cosine of x minus 2y times the derivative of x minus 2y with respect to y, which would just be negative 2. Any questions on first partials? How did we do?
Okay.
Good. Got them okay? All right. Then you do your second partials. Z sub xx. So the derivative of cosine is negative sine, right? So negative sine x minus 2y. Z sub xy, I got 2 sine x minus 2y. Is that okay? Okay. All right. Z sub yx should be the same thing. And then z sub yy is negative 4 sine of x minus 2y. Any questions on just a quick trig second partial practice?
Finally.
Okay.
Locked.
All right.
Watch
Good.
this answer.
Notation.
Whoa.
Okay. So, do you guys remember when we learned second derivatives last year, the regular second derivative notation for dy dx is d squared y dx squared, right? So second partial, the way that you get the d squared y dx squared is because it's d dx of dy dx, right? So mathematicians saw d dx of dy dx and said, oh, look, it's kind of like d squared y dx squared, but we all know the dx should be in parentheses, but they just let that go. So anyway, so this is your second derivative, regular second derivative notation, right? Your second partial notation is kind of similar. So when the variables match, so you have partial x of partial f partial x equals, so that it's partial squared f, del squared f over del x squared, right? Or f sub xx. Okay. And then the same thing with the del squared y, or del squared f over del y squared, or f sub yy. The part that gets confusing in my brain are the mixed partials. And the reason my brain doesn't like it is because when you write f sub xy, this makes sense to me. I do partial x, and then I do partial y on my partial x. So it kind of, I see it in the order that I should do it. Whereas when it's written in this notation, it's listed kind of backwards. It's like inside out, because it's partial y of partial x, so the y is to the left. So you have to learn that when you see subscript notation and you see this del notation, the del notation for the mixed partials is backwards. Yes?
I was going to say, but doesn't it not matter because it's the same thing, but if it's discontinuous, it's not.
Right, exactly. If they're the same, it doesn't matter. And for most functions, it's going to be the same. But once in a while, you'll hit one that's different. So it's good to know. Okay. So anyway, so if you want to write down any notation, I don't know if you want to.
Will the notation be on the top?
Well, I can ask you it in any way I want.
I'm gonna need 10 minutes.
You don't need 10 minutes.
Yeah, 15 minutes.
If all you wrote, right, if you wrote that, right, that would cover you. Right? Okay. I think 2 students. This was I feel like this is Calc 3, like you're working, but I feel like I'm pulling teeth a little bit to get you guys to work today. Like we're not in the mood to work. We're working, but we're not in the mood to be working. Yeah, that's what. Yep. Banjo Wednesday?
Isn't it Pizza Tuesday?
Pizza Tuesday? You are always wanting pizza.
Yes. I haven't had my pizza fix for so long.
Oh.
Wait, tonight it's pizza night at my house. So.
Tuesday is pizza night?
Yeah, but my parents always get the same pizza and it's not that great.
Really?
They're obsessed with the spicy fennel sausage from Papa Murphy's.
Oh.
And I'm tired of it.
I've never had a Papa Murphy's pizza.
Oh, really?
No.
My parents just love it. Because it's like, they're like, I'm going to get the pizza. It's exciting, but then when they get home, they're like, pizza's here.
Except they have to cook it.
Yeah.
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 So many.
All right. Is everyone done writing? Colin, did you get enough time? Okay. I think you were the only one actually writing that down. Okay. So, all right. I thought this might wake you up. I have a whiteboard challenge.
1 point added.
Okay. So, and this even if you're next here, I'm gonna pause this. For the recording, just so you know, these are the problems we're solving right now. Oh, one group is running up to the board. All right, a second group is going up. Right? So, guys, what can you do with a natural log? Right? 1/2 ln xy. This is just 1/2 of ln x plus
That's still hard though.
Yeah, he knew that.
X is-
Really?
Yeah.
And you were doing Havel and X is just 1 over X.
No, but I didn't know how to get.
Okay. So good. All right. Good work today, guys.